Hi and welcome to the webinar. My name is Radu Trankau and I'm a technical consultant at Trimble UK. Today we will be talking about base points. This is a topic that comes very often in our support queue, and I will be doing a demonstration regarding importing and exporting of a reference model in an IFC format along with some tips and tricks. But before we head into the actual demonstration, just a few admin points that I want to talk to you. So just make sure you're viewing the webinar in full screen mode just to get the optimal experience. And please use the panel on the side to interact with us and to ask us any questions. So please do write any questions in the questions box over there, and we will be looking at answering these at the end of the demonstration. Okay, so what are base points? Why do we use them, and how do we use them? There is an excellent article on our Tekla user assistance page, and if you search for base points, you will see the article as I have it right now open on the screen. So I will not be talking more about the specifics. I will leave you to read it and have it for your reference for any imports. So I will just start straight away by importing an IFC that I've exported from another model in Tekla using another coordinates. So basically, quickly, a base point is a relative coordinate system that you want to tell your model where to bring a reference model or where to export the reference model. This is just purely for coordination purposes, done in probably in Tekla or probably in a third-party software. So if you go to reference models here and you just add the model, talking about the defaults, here you will have the location set by model origin, and that's how Tekla comes in. So very often you will have the IFC sent to you from an architect or from a different contractor, or no matter who sends it to you, it will be in a different coordinate system, and that would be the system that has been used throughout the project for a common system. Okay, so if you just do these basic actions in the beginning, the majority of the users will get something like that. Okay, so you will get a big expanded work area like that. So in one corner over here we will have the grid systems, and obviously at the opposite corner we will have the reference model. You'll see the reference model is translated from the 000 model origin of Tekla on X, Y, and sometimes on Z axis, and also it's got a twisted angle. Okay, so how do I bring this reference model back to the Tekla origin? We will be looking at three options to do that. And before bringing the IFC back to the origin, we will be talking about the reason why we want to do that. It is recommended that you model in Tekla as close as possible to the model origin. Why is that? Is because Tekla does lose accuracy when snapping and modeling, and also when you will start creating drawings if you are far away from the origin. So that's one main purpose for using base points. Okay, so instead of just doing this model here and start the modeling, you will need to import that model next to Tekla's origin. That is a very common mistake that I've seen getting asked through support, and I will quickly demonstrate you what happens if you start modeling at this distance. So let's say the majority of people will just start modeling over this IFC straight away. Okay, So what you'll see is if I zoom in, you'll see that the solids will start to lose accuracy. It will become very pixelated, and it will become very, very hard to work with snapping. Okay, so let's, for example, try to create a beam right now. So if you want to snap a beam, for example, I will just move into this mode. You'll see that snapping will be a little bit offset from the point that you are actually wanting to snap to. So overall, this is not a preferred way of modeling, and I wouldn't recommend you modeling this way. So I've just modeled a beam right now, and you can see it's not showing. So that's another effect of having the model so far away from the origin. So if I just redraw the view, you'll see it's disappearing. So you'll need to redraw the view a couple of times, or fit work area to entire model a couple of times, just to make the beam or the model appear or disappear. And sometimes you can't do it. Okay, I will, for the sake of this exercise, I will just try to put another point in here as well, because we will be using this point later on in our demonstration. Again, if you try to, for example, put a point in over this intersection here, you will see that it's very, very difficult to snap something. Okay, so just to have a little bit of an awareness of how far this this point is located from the origin, you will see it sits somewhere 473 kilometers on X and 578 kilometers on Y, and this is too much. Okay, so everything that exceeds probably 100 or 150 kilometers away, you will start to have serious conflicts in the output of the graphics. Okay, so let's fix this situation right now. You can do that in 3 different ways. So the purpose of the exercise of the three methods is to bring the IFC closer to the Tekla origin. So the most straightforward method is just to create a base point based on the information that it's been given to you. Okay, so that's the most straightforward thing that you need to do, just to get this piece of information that sometimes may come from the architect, or may come from the BIM manager, or it may come from whoever. You've got this information at the ready. So you've got the northing coordinate, you've got an easting coordinate, and you've got an angle to true north, and sometimes you have an elevation as well. Right, so without wasting the time on this one, which is very, very straightforward, I've just introduced those coordinates already in the base point. So in order to define a base point, you go to File, Project Properties, and then Base Points, and just click this button here. You can already see I've got a coordinate system which I filled in with all that information. The angle east coordinate, which is the X on Tekla, and northing coordinate, which is the Y on Tekla. Okay, I've unticked the project base point because I just wanted to import the IFC in the default model origin one. Okay, so once you have these, you can just click on the project base point, click on modify, and then you can just import a model by using the base point real world project coordinates. Okay, so this is one method, and then you can just come in and bring in the model, but you can also do that just from inside already imported model. Okay, so if you just double click onto it, location by, you just change that to base point real world project coordinates, and you just hit on modify. This takes a little bit of time, but that should bring you the model bang into the origin. Okay, so that brings this point, which is the reference base point in my coordinates, the intersection between axis C and 2, brings it back into the Tekla origin. So this is pretty straightforward. Okay, so the goal is to bring the IFC closer to the origin, and also to make sure that this huge work area is reduced to just where the origin is. Okay, so if we fit work area to an entire model, we see that we still have something left here, and that's points and the beams that we've or the beam that we've modeled before. And if we do not sort this issue out, we will still have accuracy problems, as you see with the model. Okay, so I will just try to quickly draw a column here and a column here. You can see it's not showing. Okay, so it's giving me the same glitches as per before. So that's one common issue with not exporting or importing the IFC close to origin and leaving this huge work area with objects which are very far away. A quick fix to this one. Okay, so if you just redraw view, obviously there's nothing in here, so you have to zoom in and zoom out a little bit. We have to get rid of whatever is in here. Okay, so if we just make a huge window in here, you can see I've just selected the beam. Okay, delete the beam, fit work area to entire view, and we still have a point, right? So remember, we've modeled a point in here, and now it's barely selectable. Okay, this is a very common issue with construction objects, points or construction lines being left just very far away from the model origin. The fix for this is just to quickly go to File, Diagnose and Repair, Find Distant Objects. Okay, so you should get a window with a point, right? So that is the point that I've just missed in that corner, and I wish it to be deleted. You can just inquire the object and you will find what it is in here. So quick way, go here, right click, delete, and that should clear the problem from you for the next fit work area to entire model. Okay, that's a very simple solution to a very common problem that we've seen. So now if we just go in and zoom in, you can see how normal the model is like. So this is exactly what it should look like. Okay, right, so now there are other two methods to sort the problem of the IFC coming away from the origin, and it's very often that you don't have the coordinates. Okay, so you don't have those coordinates and you are forced to work out those coordinates. So let's just quickly go and delete this model and bring it back again. Okay, so I'm just going to bring this model using the model origin as we previously did, because I just wanted to come into that place. Okay, the far away place in here. Okay, so I will be going straight into the IFC method. Okay, just looking into the IFC. So if you just go to File, Open Model folder, where we have our IFC stored, and what I usually do is right click on it and open it with Notepad. Okay, so that will bring you with this specific format. So this is what an IFC contains, and I will be talking from a Tekla perspective, because an IFC exported from a different software might have the place where to look for the base point coordinates slightly different. So in Tekla's perspective, if you search for Ifc Cartesian point, okay, and if you just search for the second appearance from the top onto that one, that will bring you the X, Y, and Z coordinates. Okay, so you can look into here and just get these base point coordinates. Okay, there's no way to finding out the angle to the true north, but I will be talking about that angle and how to closely guess it in a minute. So remember Ifc Cartesian point, the second line, the second appearance of that class will give you the X, Y, and Z coordinates, and implicitly the east, north, and elevation coordination that you might want to include in your base points. Okay, so the second method is to just get a reference point. Okay, so we know from my PDF previously that this point here, if I just so this point intersection C2 will need to sit in the origin, but obviously you might not know that, so you just want this point here, or as close as possible, to be to sit in the model origin. So the goal is to bring this Ifc closer to Tekla model origin. Okay, so as we saw previously, you can't really snap on this point because we're too far away, and the accuracy is absolutely making the situation to not work very well. What I will do is switch to this option, select objects in components, and I will just quickly select this base plate, and I will just inquire it. Okay, and this will give me some coordinates. So I know that the top of the plate sits, so the center point of this one sits at 473, 490, 188, and Y is 578, 499, 821. Okay, so based on that information, I will just quickly define a base point. Okay, so I'll just want to define a new base point called guess base point here. Okay, I'll just delete that, and just quickly, if I have this information already, so remember X is east, so I will say 473, 490, 188. Okay, and on this side it will be 478, 499, 821. Okay, so for the sake of this exercise, I will just click on 0 here as well. So I'll just go on and modify the base points. So now I have the original one, and then I'll have the guess base point in here. Okay, all I have to do now as previously, so that will be the third method. Forgot to conclude the second method. So the second method would be to look inside the Ifc through the notepad file and get the information from the second appearance of the Ifc Cartesian point class. That happens for whatever is being exported by Tekla, and that might be in another place that might look different from another perspective. And the third method is the guessing game. So we do have that base point defined. Now all we have to do is just to change it from here, guess base point. Okay, so click on modify, and now the this point of the base plate should go straight into the origin. Okay, so fit work area to entire model. We've sorted the problem with the work area, so we are making sure there's nothing left floating in space. So as you see, the center of that base plate, or the coordinates of that, should sit in the base plate. Obviously, it's a bit offset, again, due to the loss of accuracy. So now it's very, very easy to start working on bringing this intersection point into the actual origin. So what I will do now is I will just grab a point and I will just put it here at this intersection. Okay, and that is absolutely going perfectly fine. We just need to see what's the coordinate of these points right now. Okay, so you see it's sitting 191.2 offset and 190.64 offset. Okay, so we need to adjust the guessing base points right now. Okay, so for the guess base point, what I will do right now is I will just add that 191.2 to the east, and then add the 190.64 on the north coordinates. Okay, so this is how you bring that point now bang onto the Tekla origin. Okay, so let's just quickly put in the values here. So that would be 490,379.2, and then that will be 578,500,011.6 if my math is not wrong. I'll just it asks you to modify the related reference model locations because this IFC is related to this one, and you should see it's moving bang onto this point. So that's a way of working out the XYZ. Obviously, if the IFC sits above or below, you will always follow the same logic by just picking yourself a reference point. Now, with the actual angles, that's just purely an exercise of measuring what's the angle on which the IFC is rotated. So you will have to do this guessing work now. So going back to your project properties and base points, for the guess base point, you will just put in 43.24843 as you've measured it, and then click modify. Okay, so that's a very iterative process that you will need to do. Okay, it's not perfect from the beginning, but it's getting there. So obviously the finality of this exercise should be that at the end you should have all these base points, the guess base point along with the angle should somehow match or be as close as possible as this one. Okay, I do not have another reference model, but it always works out if you have multiple reference models to cross check the information and cross check the coordinates. Okay, so these are the three methods of figuring out how to bring the IFC closer to the origin. I would recommend you to do that first before starting modeling, as whenever you're going to start modeling, whenever you're going to start adding new objects to the model, it will be very, very difficult to start changing the coordinates from that point. So if you have the chance and the opportunity to do that at the first thing in the project, that will be that will save you a lot of time in rectifying other mistakes along the way. Okay, so we've talked about importing. Now let's talk about exporting, and that's just one issue here. One mistake that I've seen people doing. It's not actually a mistake, but it's more of an omission to tick a short box. Okay, so to export in the same coordinate system, in the same base point, I will just quickly arrange the IFC to its real world project coordinates. Okay, just so that we have a flushed model, and we are using the real ones. Okay, so what I'm doing right now, I'm just trying to export these columns and along with these grid lines. These grid lines obviously will need to you will need to match the IFC's grid lines when you start, but just for the sake of this exercise, I will just do an export of these columns. Okay, so I'll do two types of exports. If you go to export IFC and then just click on coordination view 2.0, always, you don't necessarily have to do that, but it's just bringing more information to the IFC. I would say all objects for now, and at this point people just click export. Okay, so I will just name this file out model origin. So if we click export now, it will just simply export the columns, the objects in the model origin coordinate system. Okay, so this is a common omission when you do the export. What you need to do if you want your model to go exactly where the IFC and the exact location of the base point of the IFC, you'll just have to pick from the drop down the actual base point, which is called real world project coordinates. Okay, and I will just real world coordinates, I will just do another export to see how it looks like. Okay, so we have two IFCs looking identical, but one is at 0, 0, 0 and one is going 573 kilometers on Y and 473 on X. So I will just quickly show you how that looks like in Trimble Connect. So we have I have a Trimble Connect open here with the IFC, the coordination IFC already in. All I need to do is just to add the model origin and the real world coordinates to this box. Okay, so it will just take a little bit of time. I will just make a full view on this one. So, or as a matter of fact, I will just remove this file. Okay, and I will just click on view. So let's just view everything here, and what we have is the two columns and the grids, okay, exported in the 0, 0, 0, but in terms of coordination we would have wanted that to go to this point. So you see how far away they come if we export the Tekla objects using the model origin and not using the coordinates of the IFC. Okay, so that will get you a failed coordination exercise. Now if we remove this file and then add the real world coordinates, okay, takes a little bit of time, and if we just move that in here so we can view the whole folder, you can see now that it's looking exactly like our Tekla model. Okay, so in this way we're making sure that whatever we've modeled, whatever we've exported, it goes into the right place when we export the IFC, making the coordination task for the project manager or for the beam manager really easy and correct. Okay, so I'll just minimize this Trimble Connect. So key aspect here is to remember to export and import using a defined base point. Okay, so make sure whenever you're doing both the import and both the export exercise to get to a project coordination base point which you may receive from somebody else, from somebody who's giving you the IFC, or as we've seen, you may deduct either from the IFC file straight away using that class for Tekla exports, or just by going back and forth and trying to guess your coordinates. So please do get your IFC as close as possible to the origin and work as close as possible to the Tekla origin to avoid those problems that we've seen in the beginning of this webinar. Okay, so I think this is pretty much it. These are the most frequent scenarios that I've seen coming into the support, and hopefully you could get a better understanding on the whole process and what's behind the process and how you can actually figure out what the base points are. Okay, so that's all from me. We will now look at some of your questions, if any, that you've posted in the question box on the side panel. If there are any questions that I feel that it will require some further research for me or a longer answer, I will make sure I will send you an email, and I will follow up the conversation through an email. So thank you, and I hope you enjoy this webinar.